Hey everybody, so we're going to be talking about solving a system of equations by graphing today. Now, what that means is that we're going to be able to graph two equations and we can find our solutions, just like we looked at in our introduction. We saw a graph, we were able to find that point. This time, you're going to have to do the graphing. Now, the first thing that you're always going to have to do is to have it in slope-intercept form. All right, that makes your life easier when you're graphing. So your notes should look like this. We've got 4 examples that we're going to go through. 2 of them are one solutions, one is a no, and the last one is an infinitely many solutions or infinite solution. So you can also see this written as infinite solution. All right, so our first example right here, solve the following system of linear equations by graphing. We've got 2 equations. The first one is in slope-intercept form, but the second one, we're going to have to move that 2x over, and we get y equals negative 2x plus 4 once we're in slope-intercept form. If you need to do that to the side, that's totally okay. If you ever need to pause it while I'm trying to convert any of these equations, then you are more than welcome to do so. All right, in order to help us, I'm going to be using 2 colors at all times for systems of equations. This is super helpful when you're in Algebra 1 because you have 2 equations that you're graphing, so that color helps you. And if you've got a TI-84 plus silver edition, the color one, guess what? It uses color too. If you don't have the color one like we do at school, then what you can do is simply put y1 and y2. And I put mine into different colors since I'm doing it on paper anyways. Why not? All right, so my first one, it's a y-intercept of negative 3 and a slope of 1 over 3. So I went up 1 to the right 3, and there it is, my negative 3 right there. That's y1. And if you want to label yours, if you're not using any colors, label your lines at the end next to the arrow so you know which line is which. Then you've got y2, where our y-intercept is a positive 4, and we're going down 2 to the right 1. And you'll notice our intersection here is 3, negative 2. So our answer is 3, negative 2. That's how easy it is. Now all you're doing is graphing 2 lines on the same graph. That's it. And you know how to graph lines. You can do this. And if you don't, go back and take a refresher from chapters 3 and 4. All right, so let's do example 2. In this one, neither of them are in y-intercept form. Well, what's going to end up happening is that we're going to convert both of them into y equals, into slope-intercept form. That first one becomes negative 2x minus 1. And then that second one becomes y equals x plus 5. And if you're wondering what's happening is we're adding the 15 to both sides. So we get 3x plus 15 is equal to 3y. And when you divide each of these by 3, you get x plus 5. All right, so let's graph both of our lines. Again, if you want to do y1 and y2 on here because you're not using color, then please do so. That way you can differentiate between the 2 lines. And if you're ever doing this on paper for me, I'm going to be expecting to see y1 and y2 if you're not using color. All right, so I've graphed y2 first this time. It doesn't matter which one you graph, as long as you graph both of them. And that's what I have. This is my y1 here. Here is my y2. And notice this time our intersection is to the back. So you're always going to have to make sure that your lines extend all the way across both the graphs. And in this one, our solution is negative 2, 3. No particular reason, just, have a really strong inkling to use the numbers 2 and 3 today. So you're good. All right, speaking of 3, let's go to example 3. All right, first equation is in y equals in slope-intercept form. Second one, we're going to convert, and we get this. Then you get y1 and y2, and I'm labeling it this way so I can keep track of both of them again. Graph both of your lines. Here's my y-intercept of 2, down 3 to the right 1, because you're always going to go to the Right. Same thing for this one. -4 is my y-intercept. I didn't have room to go down 3 on this and to the right 1. So if I turn my paper upside down, and I can't do this on my iPad, but if you were to turn your paper upside down and go down 3 to the right 1 and turn your paper back around, then you would have this point as well. Now, in this case, these lines are never going to intersect. And that's because they have the same slope. And if they have the same slope, that means that they are parallel. Parallel means no intersections. No intersection, no solution. And you would literally put no solution for your answer, because you cannot ever find an intersection for this. This actually comes from way back when we did the other solutions to solving, and we got all real numbers and stuff like that. That's where a lot of this comes from. All right, last one, example 4. Neither of these are in slope-intercept form, but don't worry, we're going to convert. All right, for this first one, we get y equals 1/2 x minus 1. In the second one, I've got y equals 1/2 x minus 1. Now, you'll notice that our first line is the exact same thing as our second line. It's got the same slope and the same y-intercept. In example 3, they had different y-intercepts. These two have the exact same y-intercept and the exact same slope. So, guess what? That line, that second line, is the exact same line you would draw right over it. And because it's the exact same line, same slope, same y-intercept, it's going to touch itself an infinite number of times. So, that's all I've got for you. Make sure you've got this written down. Good job.